it's not quite right just yet, because we haven't balanced it. In order to be balanced, chemical equations need to have the same total number of each type of atom on either side of the arrow. In our example, we can see that on the left of the arrow, there's 1 carbon, 4 hydrogens, and 2 oxygens, whilst on the right, there's 1 carbon, 2 hydrogens, and 3 oxygens. So our equation isn't balanced. Somehow we need to increase the number of oxygens on the left-hand side, and increase the number of hydrogens on the right. Now, it's absolutely fine if you can't work out how to balance it in one go. Often, balancing equations is a process of trial and error, where you keep on changing numbers until you get the answer. The first rule of balancing equations is that we can't change any of the little numbers. This is because doing so would mean that we were changing the actual type of chemicals in our equation. For example, we couldn't change our O2 to an O3, because O3 is an entirely different substance, which isn't oxygen. Instead, we have to rely on changing the big numbers in front of the different elements or compounds, as this number just represents how many of that substance there are. So to increase the number of oxygen atoms on the left, we'd have to put a 2 in front of the O2, meaning we now have 2 oxygen molecules, and therefore 4 oxygen atoms in total on the left-hand side. This might seem a bit weird, as we only need 3 oxygen atoms to match the right-hand side. So shouldn't we just make it 1.5 molecules of oxygen? Unfortunately, we can't. When balancing chemical equations, another rule is that we need to keep to whole numbers. And so we have to round up to 2 instead, and keep 4 oxygen atoms. This leaves us needing 2 more hydrogens and 1 more oxygen on the right, which we can get by increasing the number of water molecules from 1 to 2. So we now have the same number of each type of atom on both sides of the reaction, and so we're done.